In the last lecture, we had discussed about Gay-Lussac's law of gaseous volumes, and we had discussed numericals and examples on it. Now, we will talk about Avogadro's law. Now, Gay-Lussac's law was quite similar to the law of definite proportions. Instead, in place of proportions, here we talked about volumes. Now, Avogadro's law is a bit more advanced on this concept. So, Avogadro's law is our next topic. Avogadro's law, okay. So, this was proposed by Avogadro in 1811, okay. So, Avogadro's law states that equal volumes of all gases at same temperature and pressure should contain equal number of molecules. Equal volumes of all gases at same temperature and pressure should contain equal number of molecules. Okay. So, this can be represented as, let's say we have gas A which combines with gas B and gives AB. Okay. Now, Avogadro said that no matter what gas we are taken, for specific volume, let's say 1 liter. 1 liter of all gases at same temperature and pressure will contain equal number of molecules. Similarly, 2 liters of all gases at same temperature and pressure will contain equal number of molecules. Okay. So, let's say if we have gas A, let's say 1 volume of gas A, okay. Okay, then there are 5 molecules of gas A in 1 volume, for example, and we have gas B, again 1 volume. We can assume this from the Gay-Lussac's law also. Now, for 1 volume of gas B also, there will be 5 molecules. Okay. These two gases combine to form gas AB. Let's say AB also formed 1 volume. Now, AB also will contain five molecules of AB in 1 volume. So, this was the Avogadro's law, that equal volumes of all gases at same temperature and pressure should contain equal number of molecules. So, Avogadro's law could also explain that gases are polyatomic in nature. It could explain the polyatomic nature of some gases such as hydrogen, oxygen, nitrogen, etc. So, let's talk about the formation of water. It's an easy example. We know that this is the equation for the formation of water. Okay. So now let's say by Gay-Lussac's law, what we know that 2 volumes of hydrogen, 1 volume of oxygen forms 2 volumes of water. So we have 2 volumes of hydrogen, okay, plus 1 volume of oxygen. This will give 2 volumes of water. Okay. Now, let's say again, suppose we have 3 molecules of hydrogen in 1 volume. Okay, this is 1 volume, this is 1 volume. So 3 molecules here also. Now 1 volume of oxygen will also contain 3 molecules by Avogadro's law. Now we have water. It is forming 2 volumes of water. So this was 1 volume. Now for 2 volumes of water, we will again have 1 volume of water will, so total 6 molecules of water will be formed. So this can be explained by Avogadro's law. Okay. So in Gay-Lussac's law, the polyatomic nature of these gases were not very clear, but in Avogadro's law, this could be easily explained. So now let's do some examples and numericals based on this law. So the first question is, hydrogen and nitrogen combine in the ratio 3:1 by volume to form ammonia. Calculate the number of molecules of hydrogen which combines with 6 into 10 to the power 22 molecules of nitrogen. Okay. So hydrogen and nitrogen combine in the ratio 3:1 to form ammonia. Calculate the number of molecules of hydrogen which combines with these many molecules of nitrogen. So the ratio is already given. So 3H2 plus 1N2 gives 2NH3. Okay. So this is 3 volumes, this is 1 volume, and this is 2 volumes. So the molecules of nitrogen is given. So in this reaction we require 1 volume of nitrogen. So 1 volume of nitrogen contains 6 into 10 to the power 22 molecules. By Avogadro's law, equal volumes of all gases contain same equal number of molecules at same temperature and pressure. Okay, so at this temperature and pressure, 1 volume of nitrogen contains these many molecules. So 1 volume of hydrogen also contains these many molecules, right? So 3 volumes of hydrogen will contain 3 into 6 into 10 to the power 22 molecules, which comes as 18 into 10 to the power 22 or 1.8 into 10 to the power 23 molecules. So since 3 volume of hydrogen is required in this reaction to react with 1 volume of nitrogen, so 1.8 into 10 to the power 23 molecules of hydrogen will react with 6 into 10 to the power 22 molecules of nitrogen. Now we will see a next question. Okay, in this previous question, when nothing is mentioned and such questions are asked, then we have to assume STP, that is same temperature and pressure. Okay. Now the next question is 6 into 10 to the power 20 molecules are present in 22.4 centimeter cube of ammonia. What is the number of molecules of hydrogen in 224 centimeter cube of hydrogen under similar temperature and pressure? Okay, so what is said that 22.4 centimeter cube of ammonia contains 6 into 10 to the power 20 molecules of ammonia. Okay, so 22.4 centimeter cube of ammonia contains 6 into 10 to the power 20 molecules. So at similar temperature and pressure, 22.4 centimeter cube of hydrogen will also contain 6 into 10 to the power 20 molecules. Okay, so 1 centimeter cube of hydrogen will contain 6 into 10 to the power 20 divided by 22.4 molecules. So the required volume is 224. 224 centimeter cube of hydrogen will contain 6 into 10 to the power 20 divided by 22.4 into 224 molecules of hydrogen. Okay, so this is 10. So we have 6 into 10 to the power 21 molecules. Okay. So 224 centimeter cube of hydrogen under similar temperature and pressure will contain 6 into 10 to the power 21 molecules of hydrogen. So this was the Avogadro's law. We have studied Avogadro's law. Now we will study about Dalton's atomic theory. So initially people believed that every matter is made up of certain small indivisible units. It was called atomio, which means indivisible in Greek. So from this, Dalton proposed that every matter is made up of small units called atom, which cannot be further divided and which constitutes all matter. So we will see the postulates of Dalton's atomic theory. So the Dalton's atomic theory was proposed by John Dalton in 1808. So the first postulate was matter consists of indivisible atoms. Okay. Number 2 was all atoms of a given element have identical properties including identical mass. Atoms of different elements differ in mass. Number 3 was compounds are formed when atoms of different elements combine in a fixed ratio. And number 4 was chemical reactions involve reorganization of atoms. Okay. So these were the postulates of Dalton's atomic theory. We will discuss about this in details in the next lecture. Thank you.